My name is Caroline Zer, and this is my Physics 2211 Lab 5 on a falling slinky. Introduction. So the purpose of this lab is to observe and analyze the motion of a slinky using Newton's second law. And we observe the effects of gravity, which is the weight force, which equals negative mass times the gravitational constant, drag force, which is equal to negative b times the magnitude of v squared times v hat, and spring force, which we also can kind of call tension force in this lab. And it's not listed here, but force of spring equals the negative spring constant times the stretch of the spring. And then the key concept is Newton's second law, which states that V final is equal to V initial plus F naught delta T over M, and R final equals R initial plus V final delta T. We will use these velocity and position update formulas in our iteration, and we will use the forces to determine F net as seen in the velocity update formula. For Tracker, there is a screenshot of what I did on Tracker. I tracked the bottom of the slinky, which was at rest at first, and then began to fall. So for the initial conditions, the mass is 0.204 kilograms. The initial position is 5.5 times 10 to the negative 3, comma, negative 3.35 times 10 to the negative 3, comma, 0 meters. The initial velocity is 0. Our system is the slinky. And for the surroundings, it is the earth and the people. Then for my code, again, here are the initial conditions, same mass, velocity, and position. I put in the gravitational force, and there was my estimate for the drag force constant, B equals 70. And then here are my iterations. So on the left is my first one. We said that F net equals W plus force of tension. We have the velocity and position update formulas. And then on the right, very similar, F net equals W plus FD. And then again, velocity and position update formulas. And yep. So then here are my observed versus expected results. As you can see, these two graphs look very similar. On the left is my Y position versus time graph from Tracker, and on the right is my Y position versus time graph from my code. And then I put them into a single graph so that we could observe the differences more closely. So the graphs are identical at the beginning, and this is when the bottom of the slinky is not moving, so we would expect to get the exact same result. It does become slightly off once the slinky starts moving. However, they do show a similar pattern, which is what we expected. And then for this error with the slightly off graphs, I would say it's likely from inaccurately selecting the bottom of the slinky exactly at each time step on Tracker and incorrectly predicting the drag force constant perfectly. And then for the why does this happen question, it is why does the bottom of the slinky remain stationary? And this is because the slinky is like a spring. So the top of the slinky has a tension force slash drag force, or spring force, my bad, acting on the bottom of the slinky that's holding it up. And then this tension slash spring force is equal and opposite to the force of gravity that's acting on the slinky at the bottom. So the bottom of the slinky remains in static equilibrium, which is why it does not move until the entire slinky catches up to it. Thank you for listening.